The chemistry of the ocean is a very complex and interchanging environment. Our oceans are important because they have the largest abundance of living organisms on Earth. The ocean is mainly comprised of water and a variety of salts. Water, the source of all life on Earth. One molecule of water is made up of 2 hydrogen atoms and 1 oxygen atom. The opposite polarities of the atoms cause them to attract, allowing for the weak hydrogen bond between the atoms. Water interacts with other elements in the ocean, causing it to change states. Even though the ocean is mainly H2O, many other elements are present in ocean water. Some common elements in ocean water are chlorine, sodium, and magnesium. Some dissolved gases that are in ocean water are oxygen, carbon dioxide, and nitrogen gas. The solubility of dissolved gases decreases with an increase in temperature. On the other hand, salinity increases with increasing pressure. The pH level of salt water can vary from about 7.5 to 8.1. The heat capacity of salt water is higher than all other solids and liquids except for ammonia. The ocean is more salty in some parts than others. For example, near glaciers, lots of fresh water is dumped into the ocean, diluting the amount of salt present there. Living organisms also affect the chemistry of the ocean. If farmers use too much fertilizer, it will get washed into the rivers and oceans. Nitrogen-loving organisms will grow a large amount due to this. Due to their growth, they use up a larger quantity of the dissolved oxygen in the salt water. This may cause other organisms to die. Our oceans contain about 97.2% of all water on Earth. An increase in salinity leads to an increase in density, a decreased freezing point, a decrease in vapor pressure, and an increase in osmotic pressure. Some contributors to the large amounts of elements in the ocean water are volcanoes, which give off chlorine, sulfur, and carbon dioxide. Dust and rain give off iron and silicon. And rivers, the largest transporters of chemicals to the ocean, give silicone, ammonium, and potassium.
To add to Cameron's summary of the composition of chemicals in the ocean, I will talk about how the addition of carbon dioxide affects the seawater pH levels and saturation states of important minerals. Ever since the start of the Industrial Revolution, millions of marine organisms have been directly impacted by ocean acidification, due to water's pH level decreasing by 0.1 pH units. While 0.1 pH units doesn't seem like a lot of pH is missing, it actually represents about 30% increase in acid in our oceans. Another negative to ocean acidification is the lack of calcium carbonate materials due to the acidity of the ocean. As stated before, this causes organisms to not be able to produce or even maintain their shells. Lastly, predictions as to how much more carbon dioxide the ocean will absorb are very scary, as by the end of this century, scientists have predicted that our oceans will become 150% more acidic instead of the 30% more acidic that it is right now.